So the next special case that we are going to be looking at is factoring by grouping. If you have already learned the AC method or splitting the middle, you have already done some grouping. So this should be not that bad. So let's take a look. All right. Factoring by grouping shows up when you see four terms. Not always, but many times. So if you have a four-termed polynomial and you need to factor it, your first thing that you should go to is factoring by grouping. When you are factoring by grouping, you are going to try to look at these four terms, and we're going to use our squiggles again. We're going to squiggle here and squiggle there. Is there a common factor in the first two terms? There is. It's 2. If I factor out a 2, then I am left with 3x minus 4. All right. I'm going to look at the second two terms, and I'm going to say, well, what is the common factor there? And the common factor in the second two terms is r. Now, I need, remember from our other grouping we've done, we need these inside parentheses to match. So I'm going to take out a negative r so that my first term is a positive 3x and my second term is a negative 4. If you have factored by grouping correctly, then these parentheses will match. They have to be the exact same. If they are not the exact same, if they are different by a sign or by one number, then that is not good enough. You have to do something else, okay? But if they are the exact same, then they are a common factor. 3x minus 4 is common to both pieces. So I'm going to take out 3x minus 4, and my first leftover is 2. When I take out 3x minus 4, I'm left with 2 in the first term and negative r in the second term. So this is my factored form, 3x minus 4 and 2 minus r. That is how I factor by grouping. I just do that middle part of the AC method, the middle part of splitting the middle. Let's look at another one. All right. I'm looking at this polynomial. I see that there is a common factor here and here, and so I'm going to hope that I get the same thing inside my parentheses. So I'm going to factor out an m, and I'm left with x plus y. And the common factor in my second two terms is a negative 2n, and I'm left with x plus y. My parentheses match, so that is my common factor, x plus y, and my leftovers are m minus 2n. All right, that's it. Factored by grouping. Now, sometimes you're faced with a wildcard problem. So if I were doing this problem, I'd say, okay, well, I'm going to squiggle here and squiggle there, and then in my first two terms, my common factor is a, and I'm left with a plus 12, and this is not looking good already, because in my second two terms, I have nothing. There's no common factor. So this doesn't work out at all. So we need a different method here. I'm going to show you this just for fun. This is not factoring by grouping necessarily. This is going to be just looking at a different kind of grouping. So I'm going to look at these first three terms. And these first three terms are trinomial, and I can factor them. When I factor this trinomial, I get a plus 6, a plus 6. Well, a plus 6 times a plus 6 is a perfect square. I can write that as a plus 6 squared, and then minus b squared. All right, so instead of grouping the first two terms, I've grouped the first three terms, and I've factored them into a perfect square here. Well, now what I have is secretly a difference of squares problem. Surprise! So now I'm going to treat this like a difference of squares. I have a perfect square minus a perfect square. The square root of the first term is a plus 6. And the square root of the second term is b. So I have a plus 6 and b. One's a plus and one's a minus. So these end up being my factors for this problem. A plus 6 plus b and a plus 6 minus b.